Hey guys, Maker Dave here, and I'm going to show you a little machine that I use to make all of my CNC machines. Makes all the motor mounts and small parts and anything I need, primarily out of aluminum, but being a conventional knee mill, it's capable of, it's 3/4 size knee mill. It's capable of doing anything a full size knee mill will do, except that it doesn't have the size of the bed. It's a little smaller bed on it. So let's get right to it. I'm going to show you the operation of it and how the Mach 3 works with it. And it's pretty simple for anybody who understands Mach 3. You can just kind of zip past that part. We're going to first show the machine itself, the nomenclature, and how we use the machine here. So first I'm going to give you a little tour of some of the attributes of this machine. It's a central machinery. Not something you can go down to Harbor Freight and buy. This is a special order online, and that's the only way that you can get these. It's a real interesting story. I had to order 3 of these before one came in that wasn't all beat up or rusted or had any problems with it. I kept refusing the shipments and wrote the company back a little letter saying that as long as they keep sending junk, I'll keep refusing it. So the next time I received one, it was perfect. So we checked all the backlashes. Everything is tight and really great on this machine. It, like I say, works like a big one. I motorized this machine and built it with all 34 NEMA motors on it, and all of the parts were machined on this particular machine here, where we upgraded it. So it's a real nice, handy little machine to have. Everything you see here, except the vise, goes with the machine. The capacity of the machine, the cutting capacity of the machine, is 24 inches in the X, and it is 6 and change in the Y, and it's actually 13.5 inches, counting an 1.5 inches for your R8 spindle in here in this. This one has a collet adapter system. They are the ER32s, I believe, in here, and it comes with a set of 12 collets that are SAE. They go down from any size. The one I use the most is a 3/8, and then what you do is you get a 3/8 and shank because it's stronger, and a double-sided bit. This I can flip over in the collet and use both ends of the mill on this one. Here, this has the weighs on this machine. I'm going to run this thing up by hand. What I'm doing is I'm cranking it on the hand wheel here. This can be used by hand as the unit came, and you'll see what's going on here. There's a nice dovetail slide here. You can see the metal covers that cover any of the chips from going down into the Acme screw drive. Here's your weighs in here, really nice dovetail weighs. There's an adjustment for the weighs. This is for the Z adjustment for the weighs, and this is for the to adjust the tension on the Y weighs. Here you'll see little oil reservoirs. I fill these about every time before I start the machine. There's one on both sides of the machine, as well as the Y. I'm sorry. The Y has a, that was for the Z. The Y has a weigh lube cut on this side and a Y lube cup on this side. These are the stops for the X. You can adjust your stops for the X. These are all really neat things you'd find on the big machines too. 34X motor. This is a 9-speed belt system. You can see the idler pulley in the middle and the speed schedule on the top. It has a safety cutout switch. If this is open, somebody turns the machine on, for some reason the machine gets activated, plugged in, turned on while somebody's fingers are in here, this will prevent it from turning on. A very robust 2 horsepower single phase 220 motor with the outer sleeve is a cooling fins. There's a heat sink on here. This is a really neat motor, and large capacitor start system over here on it. This is adjustment for the motor tension on the belt, on the motor belts on this side. You see this nut. This nut is to adjust the head. The head tilts. The head tilts. This comes in handy if you want to make a cut going, an angle cut going into something, or just tramming the head. You also have a scale here, the Z scale, to adjust your depth. You can adjust stops on here to adjust your depth to come down just so far. It works kind of like a drill press. I also have a handle, and this will double as a drill press. If you loosen up the clutch, there's a clutch on this side, right? There's the clutch. You release the tension on this clutch, and then you can use this as a drill press. A very accurate drill press. Okay, let's see. This is the misting system. There's a magnet that holds the misting body on a valve, and this is the regulator to regulate the amount of pressure going into the misting system. This adjusts the tip, the flow at the tip, to get it to atomize. Nice thing about a misting system versus a flood coolant system is you don't have the mess, and the misting system, you can adjust it to blow the chips out of the cup. It's pretty neat. And all of the mist condenses and falls down into these troughs, and there's a drain on each side. There's a little stem on the bottom of this you can hook a drain tube up to and drain it right back into a bucket if you want to save your mist. That's your micrometer based hand wheel system. This is your wheel system. You got the Y already. Here's your Z. You crank your Z down by hand or up. You see the quill coming down. By the way, the quill is huge. It's over 3 inches in diameter, and it's sealed. It's got rubber seals in it, and this is absolutely no play. This is made to take a lot of thrust force, a lot of side forces on it, so you get a really good cut with no chatters. Same thing with the knee. You can come back to the same spot. Say if you wanted to change a bit out real quick and you need the clearance to pull the bit out or to pull the R8 collet out of this, you would adjust the knee down. You go down with the knee, then coming back up with it again. It's up to the work, and you can adjust it with your zero it with your stop. Very accurate. This is the start control. This is the emergency stop. Call it the panic button. You can see the green button is the start. The top button is the stop. Next to that is the reverse button. You can reverse cut with this. And what I used is a regular tool stand for this. I believe this one started out life as a bandsaw, a large bandsaw thing. And you can see the screw that comes down through here. Say if you had this bench mounted, you would want to cut a hole in the bottom of the bench. That allows this to come down. And right back over to, let's see this thing run. I'm gonna go ahead and turn it on. It takes a little while for it to spool up. Okay, now over to the control computer. Drive, we have the Gecko drives in here. This is powered with 3 Gecko drives. This is a Sound Logic board, very popular board made in the United States, gigantic capacitors in it, and it has gigantic transformers in it. This is not a chopper voltage system in here. This is a very stable transformer, and the capacitors smooth out the waves, so it's a very clean. It also has, those are outputs and inputs in the back where these are hooked in right here. Those are for like your limit switches, for a panic button. There's also one for like a Z. You can Z probe with this. You can use a touch probe and probe with this. The program in Mach is already set up for it. And it also has a relay to turn the spindle off and on with the program. So when the program starts, it gives an M3 signal and the relays turn the spindle on. This is a touch-off plate. What we do is we use this to zero our tool. Once we change the tool, we zero the tool to the surface of the material that you're cutting. And we're going to show you that in just a second. I'm going to go through a demonstration of how this works. So I'm going to fire up the Mach 3. Okay, Mach 3 is running. Now Mach 3 always defaults to reset on here. The reset is always off, and what that is it's not connected to the controller box down here, so it's not giving any signals to the drives or anything. We're going to use our jog controls on the keyboard. Gauge up, we're going to jog up. That's the Z jogging up. Z jogging down. Okay, we're going to bring the Y back toward us. That's the acceleration and deceleration you're hearing in the motors when they start up, to the jog speed on the motors. We're going to jog this over to right about there. We're going to set the height of this to the height of that vise that's in there using that Z control. We're just going to demonstrate this is the x-axis. Positive, x-axis in the negative. We have a fast jog we just turned to. I just press on this shift button when I hit the jog button. You can hear how smooth that is. So we're going to do a real quick, we're going to zero all of our axes. We do that by 0x, 0y, and 0 Z. It's going to reset the Z when we go through the referencing the Z0 on here. So that's done with a little button down here called Auto Tool 0 that I insert the offset to. And how this works is you mic this plate and you put that thickness of the plate into the macro. And when it comes down and the tool touches off on the top of this, it knows that it's that distance from the actual material, and it will assume that that's 0. It'll then assume that that's 0. And then it's programmed to take the Z to a safe height of 1 inch. So what you're going to find out here is we're going to set those, and this should be 1 inch in the Z when we're done with this. Hook our ground up to the frame of the machine. And we get the touch plate in position. We go to our auto tool 0. And just hold this, you can see the Z working. Just going to touch off. Come back up to 1 inch. Okay, now we're officially in the home position. We're going to disconnect this. We're officially in the home position. If that was a piece of material, you're ready to cut that. When you bring a program into the machine, you load it just like any other file in Windows. You go up to the file, you load G-code, and your file system will come up, and you can Here's a hole file using drill bits on here. So it knows that that tip of that bit, it's going to go down past that to punch a hole in something. So if I turn this on and open this file, I'm going to have to back down on the knee to get it out of the way so we can run that program. We're going to come down on a 1/2 inch here for safekeeping. Okay, we're going to ghost run it without the spindle on. Okay, you can see the G-code is loaded up there. This is a little window telling you what path it's going to take. We can go to the program run, which is the tool path. We can see that tool path in more detail right here. We can actually zoom in on it. And what this is telling us, these crosshairs, these purple crosshairs, are where the machine knows it is. Now you're going to either bring your piece up to this or bring the X and Y up to the corner of your part before you start it. It's indexed on the X, Y, and Z on the corner, on this corner. So we're going to go ahead and we're going to start this program. It's going to go down, it's going to do a simulate cut. We can also simulate the cut in the software so nothing moves. Disconnects the motors from it. But we want to see these motors move. So we're going to go ahead and we're going to cycle start. There's a feed hold which will stop the motion of the machine, the X, Y, and Z, but the spindle will stay running. And there's an all stop. When you hit this, everything will stop, turns everything off. And when you hit reset, that's like a panic button that disconnects your controller from the computer. You just don't want to do that because it could lose a couple steps while it's in motion, and then you'd have to reset everything up again. So we're just going to cycle start, and I'll show you how it scrolls through there we go. Goes through a dwell. See what's happening on this. It's coming down. It's going over to the first position where the first hole is on the piece. Here's what's happening on the screen. You see it going over to that first spot. Now it's going to give a Z command and it's going to go down. It's drilling a hole. It's going to come back up. Now it's going to go to the next position. It's off to the next hole. When it gets there, down with the Z. This is all with the spindle running. We're drilling holes now. And it doesn't matter if this is titanium, aluminum, cast iron, steel, it'll drill right to it. This is the type of machine that'll handle all of those materials. So if you want to make nice parts, this is the machine. I have a number of Ducati caps that I built. I make a lot of stuff here, and we built some Ducati gas tank cap wells, and it goes pretty deep. It goes about 1.5 inches down into the aluminum, billet aluminum, and it'll cut a layer at a time, usually about 1/8 of an inch at a time, and then go through its kind of repertoire of different moves to get that all cut out. But this is how it cuts. You can see it's going through the whole program here. We'll be cutting a number of holes along this side of the piece. You can see it'll come over here, drill a hole, come down here, drill, up here, drill, down, drill, over, drill, and so on, and then it goes back. It'll catch and then it goes back this way, and it starts to drill all of these. Not sure how this direction this one goes. And it'll go through this whole routine, and then back to home again. You see that red line right there. And that's kind of the anatomy of a program in Mach. You could do this all day long. So we're going to feed hold. This will coast it down to the stop. It makes its last move. Then it'll stop. Now we can take this and we can go back to home with it. What I do is I'll give it a command. I'm going to go in the MDI screen. Here's our home command, and this will take it to a safe Z, to a safe 1-inch Z, so that as it goes over the rest of the material, it won't crash into it. Right now it's down in just above a hole on this part of our cut. So we are going to input A. This is all in caps, so we're going to hit the caps lock, and we're going to go G0. 0 stands for the rapid movement. We're going to space. Now we're going to tell it what we want it to go in rapid to. We're going to say X, and we're going to give it a 0. We want it to go back home. X0. Y 0 and Z 1. So it's going to go. So I'm just going to go ahead and, oops, we hit it on it. We're going to be okay here. See, all 3 axes are going at one time. Get back to that home spot. I'm 1 inch above it. Everything all worked in unison to get back to that home spot. This is where we started, right here. So you'd be ready for your next part. You could take the part out of the vise, realign it with either a tool, something that you have on here. I always cheat. I'll usually make a little fixture that's a spacer that has a little notch in it right here, and I'll put it up against here, bring my piece up against that notch, and then I'll tighten the vise and start the program all over again. There's a lot of different ways of doing that. So I hope this explains everything with the program. I kind of oversimplified it. If anybody's into Mach 3, a lot of people are. It's the most popular motion program out there. There's forums, there's training sessions on it. It's all free. A bunch of really friendly folk. It's very easy to use. It's a Windows-based program. You can change the screens on it. If you're into coding, you can code a new screen for it. Add buttons to it, and you can also change a lot of the here's the diagnostic screen on it. You can see when an input is being activated or a pin is being activated on it, or if there's a command that's been tripped on it, to troubleshoot it. Very, very comfortable program to work with. It took me like no time at all to get up and running with this. At first it was very intimidating because of all the information that's given to you on the program, but if you don't let that, if you're not the kind of person to let that intimidate you, or if you have a little bit of patience, it's real easy to learn. So we're going to go back to the first screen. We're going to rewind this. This is one of those, gee, I wonder where that button is, but you'll find it. It's on here. If you go to the run the toolpath screen right here, here's the rewind button. This is where you'd run your program. Everything is right here for it. So if you rewind it, it'll take your G code and rewind everything right back to the beginning. There you are, back at the beginning of your part. And we're going to turn this off. Just hit the reset. Power down like you would any other program. End session, yes. Fixture save. When you set a 0, or any position on this, you can save that position so that you can come back the next day and pick up where you left off. So we're going to go ahead and we're going to say yes. We'll save that position. And like any other program, we'll just shut our computer down, put it to sleep. Well, I hope that cleared up some of the mysteries of how a CNC machine works. I also wanted to add that this machine is for sale. I built a number of machines in my shop here using this, and it's very trustworthy. I built a CNC machine recently, and without this I couldn't have done it. I would have had to send out for parts, and with just a few dollars worth of aluminum, probably under $100 worth of aluminum, we have a salvage yard near us. I can make a lot of money on that scrap aluminum by machining it into parts. So a lot of guys out there that know how to do the 3D programs. There's a number of programs out there. There's a program in particular, it's called Aspire. It comes in a couple different versions. A lot of guys use it for woodworking program, but it's a basic 2.5D program. We're very easy to use. You just map it out. You basically tell the program what you want it to do and what speed you want it to go, and it'll take over and do the rest. It takes you no time to catch on to this. for the really ardent 3D designers, anybody that wants to get into the 3D part of this thing, I would suggest Fusion 360. It's an Autodesk program, and they have a free version of it. They're trying to, I think, get everybody up and running and to show them how easy it is to use that. And I use it myself, and it takes a little while to catch on because there's so many neat things you can do with it, but it's one of the up-and-coming programs. It should replace a lot of them that are out there right now. A lot of guys use SolidWorks and CATIA and some of these other real high-end design programs. Fusion has got at least the amount of power that those have. It also has stress analysis and things like that if you want to get into a full-blown big version of it, and it's very cheap to own. It's like $30 a month or something if you want to get the paid subscription to it. So I highly recommend getting into 3D programming. If not, people will make these simple programs for you for nearly nothing. So you could keep these programs and use them over and over again if you want to. If you're a maker and if you want to design something that you sell or resell, you just keep programming the machine to do the same thing over and over again, and it does all the work basically for you. So I hope this was help, and if you want to get a hold of me, this thing's for sale. My name's Dave Aschenbrenner. My phone number is 239-404-3600. I have two companies. One is 3dprinttoform.com. The other is legendarymotorcycles.com, and you can reach me at either place at that number. Thank you.